talking about ARM programming with embedded C, and I wanted to program the I/O ports of ARM 7 processor. An example for ARM 7 processor, what we have taken is your LPC2148 microcontroller, right? So LPC2148 is the microcontroller which has 64 pins, and how the pins can be visualized I clearly mentioned. Let me mention it again. If you see the diagram, so this is the LPC2148. Okay, so LPC2148, right? So it has so many pins associated. Okay, so I just said the pins can be shown like this. It's a package, an integrated circuit, or a single chip, an IC, you can call it as indirectly. I mean integrated circuit, right? And you can visualize the pins which are associated with this are around 64 in number, and out of which 48 pins are IO pins, right? 48 pins are input output pins. They are defined for certain functionalities, not only for input and not only for output. They have been assigned for so many other functionalities. That's the beauty of this usage of the microcontroller for programming with the external world, you can call it as, to achieve certain task, to connect to the external devices. We have this. So I have just shown few pins outside the LPC2148, you can visualize, which are nothing but the 64 in number I said, out of which 48 pins are, so total 64 pins, correct? 64 pins, out of which 48 pins are IO pins. Basically 45 are in use, correct? So 45 are in use. So the pins are packed, the pins are grouped, you can say. The pins are grouped to call them as ports, correct? Grouped to call them as ports. So how many ports I have? I have port 0 and port 1. That's it. So port 0 and port 1. So port 0, it means that I will say it as 32-bit, which is of 32 pins, and this is also of 32 pins. So 32 pins are there, and here also 32 pins, correct? But you can observe one thing. What are all the port 0 pins? If somebody asks, then you should say P0.0, P0.02, P0.31. Total 32 pins are available with port 0. P1.0 to P1.31 are total 32 pins, but which only used pins are P1.16, 16 to P1.31 are used. Please remember. So which are all used, you should know it clearly. So it means this one I am not interested. Okay, so that's the one. So you can say P1.0 to 1.31 are not all used, are all not available. And remember one thing, the total out of 32 pins, first port 0 has 32 pins and port 1 has total 16 pins, in total 48 pins. So 32 plus 16, in total 48 pins. So out of which one point is very much clear. What is that? P0.0 to P0.31, right? 31, out of which you can call 29 pins are IO ports, out of which 29 pins are IO ports, or you can call it as 0 to 30, in which 29 pins are IO ports. What is that? 29 pins are IOs. Both they can act either input pin or output pin, whereas P0.31 is only the output pin. Please remember this. Only out pin. Okay. And 3 pins, which are all 26, 20, What are those pins? Do you remember? Who are all the pins which are not there, not available? 24, 26 and 27, correct? 27. Can you see that? 27. Okay. 3 pins. Which are all 3 pins? The 3 pins 26, 28, 26, 27 and 24, 26 and 27 are not used or reserved. Okay. Or you can call it as a reserved. So this is the important thing. So 29 pins from port 0 are utilized. Just remember that. And after that, we are not using the remaining pins of port 1. It means how many are there? The port 1, I have port 1. So it means 1.162, port 1.31. So total 16 pins. Okay. 16 pins are there. So 16 plus 29, total 45 pins. So you just remember 45 pins are in use. Please remember. So these pins are there. Now, as I mentioned, these pins not only have single functionality. If you take P0.0, if I show in the diagram, P0.0 is the pin. Now I am configuring the pins in such a way that I am defining the functionality for the pin so that the LPC can be programmed in such a way that it utilizes the IO ports for connecting to the external world to realize the given task. That is what called as ARM controller programming with embedded C to program the IO ports for realizing the particular functionality, how the people say. Now how it is done? So as we know, microcontroller or microprocessor works with the concept of fetch, decode, execution with the help of memory, registers, ALU associated. In the similar fashion, it also works with ALU, some specific registers associated with LPC 2148. Now, if you see, P0.0 has many functionality we said. So, what is that we said in the last class? P0.0 is the pin. It not only used for the purpose of GPIO, general purpose input output. It can be used for as a transmitter pin. It can be used as PWM output pin. It can be reserved also. So if these are the 4 functionality, it means at max a pin can have 4 functionalities in the given LPC board. How it will be done? Usually we know that the internal circuitry in such a way that the circuitry inside the board, it may be something like this, which has the select lines for a given mux, you can say. So mux will have 4 inputs that you know. So if I have 4 inputs, you can see like this. This is the concept. If I have 4 inputs, then the output of this, if you see, this will be connected to something like this. I'm just trying to connect. Okay. Yeah. So just see the connections. Okay. Yeah, something like this. Roughly I'm showing, you just try to bear with me. Now, so this I'll call it as output. So what is that I'm just trying to show here? So let's say I have input as GPIO, the first one, and the second one I have transmitter. The third one I have PWM. Okay, PWM, and the fourth one I have reserved RSVD. So it means 4 pins. Which pin will be selected based on the select lines what you choose? The select lines may be 0, 0. So maybe 0, 1, maybe 1, 0, maybe 1, 1. If you observe, these select lines will help this particular mux. This is a multiplexer mux. The respective input pin is selected. For 0, 0, GPIO will come at the output and feed it as an input to the P0.0. If I select line is 0, 1, transmitter will appear at the pin P0.0, or PWM will be selected at the P0.0. It means P0.0 functionality is defined by 2 bits. P0.0 functionality is defined by 2 bits to this particular mux. These 2 bits, where they are, is the question. So that question is answered by pin cell register. So pin cell register is an important register. Please remember, register. Pin cell register is the one. Am I audible through? Pin cell register is the one which defines the functionality of IO ports. So it means pin cell register is the one which defines the functionality of IO ports. We can call it as IO ports. Okay. Who defines the functionality of the IO ports? Or pin cell is the one, as the name itself indicates, it selects the functionality. Select, pin select, functionality, selects the functionality of IO ports. That's it. Selects the functionality of IO ports. So it means 2 bits are required, 2 bits are needed for defining the functionality, correct? Functionality of the pins. So 2 bits, when we say, if I take a pin cell register, it is a 32-bit register. If I say it is 32-bit register, it can store 32 bits. Correct? If it can store 32 bits, 2 bits are required. 2 bits are required for defining the functionality. Then what I should do? 2 bits are required to define the functionality. It means pin cell will define pin cell 0 is the first register. I'll say pin cell 0 is the register which defines the functionality of 16 pins only, which defines the functionality of 16 pins, because it has only 32 bits, which defines the functionality of 16 pins. But we have total 45 pins, out of which port 0 is 32 pin. So that's what I'll say. One more register I'll take, pin cell 1 defines the functionality of another 16 pins. So if we see now pin cell 1 and pin cell 2, okay. So if I say pin cell, 1 second. So if you check now, pin cell if pin cell 2, okay, pin cell 2, if I choose, it addresses another 16 pins, correct? 16 pins. So total 3 are required. That's what we say. To address the port 0, I need 2 registers, which is pin cell 0 and pin cell 1. Please remember, do not forget this. Pin cell 0 and pin cell 1 are the 2 registers which will be able to define the functionality of the pins in the port 0. First 16 pins are defined with the pin cell 0, and next 16 pins are defined with pin cell 1. Register contents, you can say like this. Similarly, if I say port 1 will be defined by pin cell 2. So port 1 has total 16 pins only. If you remember, port 1 has 16 pins, but actually it has 32 pins. 16 pins are unusable and 16 pins are usable. P1.16 to P1.31, total 16 pins are usable. That's what pin cell 2 is used to select the functionality of port 1. Who is going to select the functionality of port 0 and port 1? Means pin cell 0 and pin cell 1 are used for select the functionality of port 0, and pin cell 2 is used to select the functionality of port 1. This is all about the pin cell register. Okay, once you have the pin cell register with you, I have given you the example saying that, for example, pin cell, what is that in the diagram I have shown, if the P0.0 is there, how the pin cell will be there. Pin cell 0 register, in which if it is 00 is set, GPI will be selected, 01 is set, transmitter bit is selected. That is how the functionality is defined. Okay, so that picture we can easily visualize. So I just said there are 3 which are used accordingly, correct? So now coming to the registers that control GPIO pin. Now, for example, if before that, let me put this statement first, how the pin cell can be visualized. If you see the pin cell register which is used, I am saying, if I am saying pin cell, if I select pin cell 0, so this can be declared like this, pin cell 0, you remember 0x, it is an hexadecimal representation, 0x represents hexadecimal representation. So it means the data what we are giving is hexadecimal numbers. So if pin cell is 32-bit, how many digits I need to type here? So it must be 8, because each one is an hexadecimal number. Equivalent of hexadecimal is 4 bits. So each digit here what I am writing represents 4 bits. So what is the actual equivalent of this? If you see 000 first bit, 000 second bit, 0000 third bit, fourth bit, fifth bit, sixth bit, 7th bit, 8th bit. You cross verify 1, 2, 3. So there are total 4 plus 4, 8, 8 plus 4, 12, 12 plus 4, 16, 16 plus 4, 24, 20 plus 4, 24, 24 plus 4, 28, 28 plus 4, 32. Every time we cannot write like this. So it is totally 32 bits. 4 bits represent 1 bit or 1 digit in the pin cell. So since it is an hexadecimal representation, so another representation, if I do like this, you can cross understand, you can easily understand like this. If I say, for example, A, if I write the number like this, this is the pin cell value. So what is the pin cell value if you ask me? Then I'll say A is nothing but 1010, correct? 10, equivalent of binary, 1010, 1010. You just try to understand. 1010, 1010, 1010, 1010, 1010. If you observe now, the total 32 bits. This is the bit configuration. If you observe, this is the bit configuration. Now what you need to understand, if you group 2 pins, you just observe this. This is the pin. So this is the first. So total 16 control pins are there. So like this, if you group 2, I have 16 control pins. You can write it as 16 control pins. Please understand, 16 control pins. Control pins. So you can say this one, you can, if you want to say 2 bits, pin cell 0, it means these 2 pins are pointing to whom, if you ask. Since it is a pin cell 0, these 2 pins are pointing to 0.0. That's my answer. So similarly, if you group these 2 pins, let's say the next 2 pins, if we group these next 2 pins, okay, then these pins are P0.1, P0.1. So you just understand. So what I'm saying, just understand P0.1. So First two bits are P0.0 refers to, second two bits are P0.1. From left side, if you cross check, all 16 pins functionality can be defined by pin cell 0. So whatever you put in the pin cell value, that will act like a control bits, you can call it as, for controlling the functionality of the port P0.0 to P0.16. Pin cell 0 is used to control P0.0 to P0.15, you can say. P0.16 to P0.31 is controlled by pin cell 1. Then P1.16 to P1.3 is controlled by pin cell 2. So these pin cell defines the functionality. So like this, you just define example. For example, if I write now, you just answer if it is possible, if pin cell 1 is used. Pin cell 1. If I write pin cell 1, then so can anyone tell me 0x0000 if I write 8 bits? Now can anyone tell me what is this 0 stands for? Okay, this 0 stands for the first 0. So Naushin Banu, the underline what I have shown, the underline what I have shown, okay, which is equivalent to 4 bits. So it means I will show like this. So you can say if we take this 0th bit, okay, so it is like this. If I am talking about this 0 is written like this. So it means 4 bits, each bit is represented by 4 bits, binary data. Then the first 2 bits are used to define the functionality of the pin from the pin cell. So pin cell, when I say pin cell 1, when I say it is defining the functionality from where? P1.16 to P1.16 to P1.31. So just remember this. So if we say now pin cell 1 0 0, the last bit is 4 zeros. So the 2 bits represents what now? The 2 bits represents 0 0. 0 0 assigned to whom? 0 0 is assigned to P1.16. So it means not assigning. If 0 0 is there in pin cell 1 last 2 bits, it means P1.16 is defined with the functionality 0 0. What is that 0 0 corresponds to? It is associated with pin 1.16 whose functionality, 4 functionalities are defined. The first functionality will be assigned to P1.16. It means P1.16 will act according to the functionality which is defined by pin cell. Pin cell is for that purpose. Please understand this. Okay. So similarly, you can list anything. Pin cell 1, pin cell 2. Oh, sorry, it is pin cell 1. Huh? Pin cell 1 it is. Can anyone tell me? Pramod Reddy? Pramod Reddy?
Sir, it's lagging from that time, sir.
Pramod Reddy, you are audible, right? I am audible, right?
Sir, it's audible, sir, but it's lagging from that time, sir. The screen is the text
Screen is
whatever you are
lagging.
returning is
It's
getting from
lagging, right?
too late, sir.
Okay. But sound is coming on time.
Sound is coming, sir, but screen is unable to visible, sir.
Okay. So anyhow, this is online. Somehow we should manage. Okay.
Sir, for
So
everyone it is happening, sir.
correct. So I'll cross check again because this has to come. Slow internet, I think. Text is coming slowly. But okay. So now you are able to listen and understand, right?
Sir, it's also breaking, sir.
You are unable to listen. Where you are now? At home or where?
Home only, sir.
You are unable to listen also.
Sir, it's breaking, sir.
How come, man? Everyone is listening properly. Maulya?
Sir,
Maulya D? Maulya D?
Yes.
Am I audible correctly?
Yes, sir, you are audible.
You are listening or not? You are listening to the class, right?
Listening, sir.
Then he is saying I am not audible properly.
No, sir, for me it's audible, sir.
Okay. Then how about Mrutyunjay Kumar?
Sir, it's audible.
Okay, so just be intact with your internet because see, you know, the COVID cases are increasing like anything. We need to manage with your COVID situation also. Okay, you need to
Okay,
be
sir.
attentive. You need to be attentive. You need to have good internet connection, good ventilation at your home. Open your windows with free air. Sit calmly and continuously listen. Ensure that you have been connected to the internet and at least my voice is continuously audible to you, and even the text comes bit late, nothing to worry. You can just listen to the words and understand what I'm trying to say, and you can write down as and when I'm repeating the words. You should have that habit. Simply listening also doesn't work. Correct.
Okay,
So
sir. Okay, sir.
that's the way you should practice. You see the screen also, don't miss the classes. Otherwise, if you face the problem later with respect to the online lab which we are going to conduct, that is also the difficulty you may face. I am trying to make the things as much easier as possible for you. You just bit focus on it. Okay, that's it.
Okay, sir.
Now pencil 1 I represented by 8 digits. 8 digits, each digit is of 4 bits. Why 8 digits? Because it's a hexadecimal representation. So I can write pencil 1 like this. If I write pencil 1, if it can be written like 0x f f f. If I write f f f f f f f, 8 f's, 8 f's if I write, it means that f represents 4 ones, binary data. So total 32 bit. How 32 bit? 8 digits are there here, 8 f's are there. 8 f's means 8 into 4, 8 fours are 32. So total 32 bits are assigned to the pencil 1. Now if you write this in binary representation, how it looks like? Pencil 1 can look like 1111 f, second f 1111, third f 1111, fourth f 1111, like this. If you write all 32 bits like this, so total 32 ones are there here. That's what all f's. You can observe here 4 4 8 12 16 20 24 28 32. So 32 ones I have written. What these 32 ones in pencil 1 tells, I can show with an example stating that last two ones, if I underline last two ones, okay, from left side starting two ones, if I underline these two ones represents the functionality of port P 0.16. 0.16. Please remember pencil 0 and pencil 1 for port 0 only. Pencil 0 is for defining the functionality of the pins P0.02, P0.15. Total 16 pins. P0.02, P0.15. Okay, P0.02, P0.15. I am writing here if it is P0.02, P0.15. Total 16 pins. 16 pins are defined. The functionality are defined by pencil 0. Whereas pencil 1 is P0.16 to P0.31. The functionality. So port 0 needs 2 pencil register to define its functionalities. As you can see, 2 bits defines the functionality of one pin. For example, pencil is having all ones, then port 0.16 functionality is 11. What is 11? Corresponding task or the function will be taken by P0.16. It may be 00, it may be 01, it may be 10. How you will change these values? By changing the value of pencil register. That's it. For example, if I roughly write like this, if I say pencil 0, what is that? Pencil 0. Pencil 0 means it is pointing to the pins P0.0 to P0.15. If I define the value as if I define the value as, let me give an example, 0x f, okay, 0x f sum a 1 2 3 4 5 2. If I write like this, pin cell 0, I have written 0x f a 1 2 3 4 5 2 as the contents of pin cell 0. What is the contents of pin cell 0? f a 1 2 3 4 5 2. The total 32-bit number represented is in hexadecimal form. So if I write the binary equivalent of this, it is 111 f. A means 1010. 1 means 0001. Then 2 means 0010. 3 means 0011. Then 4 means 0100. 5 means 00101. 2 means 0010. So I have written the binary data. You can observe all the bits are changing in pin cell 0. Now how the pin cell will select the functionality of port? By underlining to 2 bits. It takes 2 bits. The first, it means to start from left side, if you see the first 2 bits 10. 10 says that it is the function which is called as PWM. What is 10? PWM. It means 10 is for home. Since it is a pin cell 0, 10 is the last 2 bits, it is P0.0. P0.0's functionality is please understand, P0.0's functionality is PWM output. It gives only PWM output. Now it doesn't act like GPIO. It doesn't act like transmitter pin. It doesn't act like reserved pin. It acts like PWM pin. Because we have seen this example in the above diagram. What is that? If it is 10, PWM will come at the output. If it is 10, PWM will come at the output. That PWM is the functionality of P1.0. Similarly, you just list all the functionality. For example, if you take next 2 bits, 00, next 2 bits. 00 means what? I know 00 means GPIO. So next 2 bits is 00. Who will be GPIO? Next pin. Who is the pin? The pin is P0.1. P0.1 is the GPIO. So it means P0.1 is declared as GPIO. Like this, if you list 2 and define the functionality, some of them will be coming as GPIO, some of them will be declared as PWM, some of them will be declared as serial pin, some of them will be declared as ADC pin. So many other functionalities will come across. We'll see those things when we are dealing with pin cell usage more in the program. Okay, this is about pin cell. Now coming to the next topic, which is called as registers. Now I'll come to the registers, because see, remember, microcontroller is all about playing with registers. That's it. Registers to control GPIO pins. GPIO pins. So when we will say the pins are GPIO pins, all the pins are IO pins, input output pins. They are not only used for input output, they are also used for many other functionalities. One of the functionalities as GPIO pins, general purpose input output. They can act like a general purpose input output. If I use the pin cell, 00 if I give, it means that pin is selected as GPIO pin. Please understand, either pin cell 0 you take, pin cell 1 you take, pin cell 2 you take, to point to the ports, to point to the pins of the ports, these pin cells are selected or chosen. If pin cell 0 is chosen, I am selecting the functionality of the pins P0.0 to P0.15. If I choose the functionality as GPIO pins, it means I am using 00 as the 2 bits. So registers to control the GPIO pins, not only selecting the pins as GPIO pins, now GPIO pins has certain functionality. What is that? If I have to control those functionality, I need to have four GPIO registers. These are called as to control the GPIO operations. What is that? IO pin, IO set, IO dir, IO set, and IO clear, CLR. See, IO input output pin, input output direction flag, input output set, input output clear. These four registers are to control GPIO operations. First of all, who made the pin as GPIO pin? Pincel register made as the pin as a GPIO pin. By setting the value in it, it has selected a particular pin as GPIO pin. Pincel may also select that pin as PWM pin. Pincel may also select that pin as transmitter pin. Pincel can select that pin as also the serial pin. So it can select the pin functionality, that is Pincel. Functionality is selected. Now let us suppose the functionality is selected is GPIO. It means the input output will act like a general purpose input output by selecting the value 00 at the Pincel register. After that, how the functionality of that GPIO should work? Now the pin is GPIO pin. What is the functionality of a GPIO pin? That is defined by the registers IO pin, okay, IO dir, IO set, IO clear. These are the four important pins. IO pin doesn't have that much importance. You can say IO pin just tells it is a GPIO. IO pin is a GPIO port pin. You can call it as value register. You can say value register. You can call like this. Okay. It is a value. It represents a value. This value, what is that? This register, what it does? This register is used for what? Is used for reading and writing. Please understand. This register is used for reading and writing. Okay. Let me get this. For both reading and writing, you just take like that. Okay, just give me a minute. So now what we understood? We understood the entire thing about Pincel. There are three Pincels, Pincel 1, Pincel 0, Pincel 1, Pincel 2, respectively used for port 0 and port 1. Then once the Pincel selects the pin as GPIO, there are four registers for controlling the operation of GPIO. Okay, so what is that? I have IO pin, IO pin, IO pin for what purpose? For reading and writing the data from and to the port. So reading, what for this? Reading and writing the data from and to the port, you can call it as, right? To the port pins. Reading and writing the values from and to the port pins. If I say IO dir, for what purpose? IO dir tells the pin whether it is input or output. Now tells whether the pin is input pin or output pin. Please understand. If I set the IO dir value pin input pin or output pin, so it means that if IO pin has certain value, IO pin is the register, 32-bit register. If it has all ones, if it has all zeros, it means that it is used for reading or writing. If, for example, IO dir, if IO dir is a 16-pin register, IO dir has 16-bit. How to represent 16-bit? 0x, FFF. If I write 8 Fs, it means it is a 32-bit. All 32 bits has made 1. It means all port pins are output pins, declared as output pins. Just to say that output pins, they are giving it out, that's all, not taking in, they are giving it out. If in case I have IO dir as 0x, all zeros, all zeros. If you for 8 zeros, it means IODIR, if it is 8 zeros, all port pins are input pins. That's it. It means IODIR is register which stores either 000 or FFF to say that whether all pins are input pins or output pins. If I want selective pins to be input pins and selective pins to be output pins, you just cross check now. If I say 0x, A0, A0, B1, 0, A0, something like this. If I write the content like this, A0, B10, A0, A, so total 8 digits I have written. Each digit is a 4-bit. You know that is a hexadecimal number. If you represent it in binary, you will come to know who are all ones, correct? Who are all ones will be output pins, Please understand. And who are all zeros will be input pins. Who are all zeros will be input pins. That's it. That's the understanding of IODIR. IODIR tells us whether the pin is input pin or output pin by having the value in it. If it is having 1 in it, it will say output pin. If it is having 0 in it for that particular pin, it is calling that pin as input pin. That's it. IODIR does that. What is this IO set? IO set puts the pin into high state. What is the meaning of this? Put the pin into high states. So what is this? It puts the pin into high state. High state. What is the meaning? Even though I declared pin as output port, output is giving out. What it is giving out? It is giving out 1 as the output. It is the data. It is putting the data 1 at the output. You can call it as putting the data 1 at the output. IO clear. IO clear means it is clearing. What is the meaning of clearing? Puts the pin into low state. So it means if I put 1 as the output, it will set. It means data 1 at the output. It clears pin into low state. It means it clears the content. So it clears the content. A small understanding is required. Whichever pins you set as the high, that high pins can be made low if you put the same value of the IO set into IO clear. It means I need to say IO. Please understand the slight difference over here. 0x FFFF 0000 if I write, it means first 4 digits are FF, next 4 digits are 000. It means first 16 bits are high, next 16 bits are low. So first 16 ports are having 1, next 16 pins of the port are having 0. Similarly, if I wanted to clear the contents, so I have to say clear with the same value what has been set, FFF 000. That's the understanding. So whatever usually IO set has, IO clear has the same thing. IO clear is for clearing the contents of the port, or you can say putting them into low state. IO set is for putting them into high state, making the output high. That's the meaning. These are the pins. That's what these pins. IODIR controls the direction. You can say direction control register. It makes either input high or low. Values are 0 and 1. IO set is the port output register, correct? Set register. This register controls the state of the output pins, either high or low. If its value is 0, no effect. If IO set value is 1, it is set to high. Similarly, IO clear is the one which clears the register. If its value is 0, no effect. If its value is 1, it has the effect. Please remember, if the value of the IO set and IO clear are 1, they have the effect. Otherwise, no effect. So you know the assignment. I have already said how to assign the values to the register. How to assign the values to the register? IO set. There are 3 methods or various methods. I can assign IODIR. How to assign the value to a register? If you take an example, IODIR 1 double shift left 3. It means I'll put the data 1 into the IODIR. If you shift 3, it means that it is shift left by 3. So the meaning is P 0. So let's say P 0.3, 0.3 I'll say, if I call it as IODIR 0. If I am setting IODIR 0 with some value, how I am setting 0 value? If I assign the value 1 and shift that 1 by 3 bits means I am choosing 3, P 0, 0.0, 0 0.1, 0 0.2, shift by 3, 3 means 0 0.0, 0 0.1, 0 0.2, okay, right, 3 times I'm shifting, so the meaning is P 0.2 will have the value 1, that's the meaning. Or the other way, simple way is, for all the registers, you directly assign IODIR 0, IO set 0, IO clear 0, IO pin 0, IO dir 1, IO set 1, IO clear 1, for all 1, 2 and 3. Sorry, what is that? 0, 1, 2. Because pin cells are pin cell 0, pin cell 1, pin cell 2. Similarly, I have IODIR 0, IODIR 1. 2 are sufficient. Okay, IODIR 0, IODIR 1. Because these two are 16-bit. So how to assign this? I can assign like this also, 0x, 0x, as I just said, 0, 0, F0, okay, F0, and I can assign A, something like this. So what is the meaning? You can observe, if you write the equivalent of this, what is that? 1, 1, 1, 1, sorry, first 4 zeros, next 4 zeros, next 1, 1, 1, 1, next 4 zeros, okay, next 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So like this, if I declare, you can see whoever are ones, those respective pins are output pins. Those values which are all zeros, they are declared as input pins. That's it. This is the simple way of specifying all the GPIO pins. And in the next class, we will look into how the timers and counters can be designed. Before that, we will look into how actually this programming can be visualized in ARM. How to write a C code to realize the functionality of the pins. Let us see the visualization. So that we will do it in the next class. Before that, I'll just show you one diagram. You can just cross verify. We were talking about LPC 2148. How exactly LPC 2148 looks like, and what all things it has around. Okay, you just see the picture. Now, whether this picture is visible to you, Pramod Reddy?
Yes, sir.
What is visible?
Sir, PCB is there, sir. With
Correct,
LCD
yes.
and buttons.
Excellent, excellent. You see now, I'm just moving it. Is it moving?
Yes, sir.
Yeah, this is the LPC 2148 board. The board layout is given. All of you just visualize. This is the board. Nothing to think much in this. There is a simple complexity. You just observe. Where is our heart? Where is the heart? You just try to observe. You just observe. There is a one IC which is shown ARM7 LPC 2148. Can you visualize that? Mrutyunjay Kumar,
Yes, sir.
can you visualize that IC?
Yes, sir.
ARM LPC 2148. That's it.
Yes, sir. Yes, sir.
Remaining all whichever is given in boxes, the text, everything is external world. This is the board in which ARM7 LPC 2148 is sitting, and this is a 64 pin IC which is connected to so many peripherals. But remember, this ARM7 inside, what it has, if somebody asks, you should say it has registers, it has ALU block, it has timing and control in it, it has RAM, inbuilt RAM, it has inbuilt ROM, it has ADC ports, DAC ports. It means it has ADCs and DACs inbuilt. It has timers inside. It has serial interfaces inside. All these things are there inside, and their functionalities are realized with the output ports. It means IO ports only. All the functionalities of the things what are there inside this LPC2148 are defined by the IO ports. These IO ports are connected to the external world. What are the external world is visible? You just try to observe. The external world you can see. What is that external world? You try to observe. The external world is visible to you now. I am showing. What is the external world? ARM7 LPC214 is connected to. It is switched on by this power supply, 12 AC volt power supply, DC power supply. There is a regulator. It means this power supply design is made here to provide a required voltage, maybe 12 volts or maybe 5 volts, whatever it is required will be given by this power supply, which is on the same board. I have JTAG connectors, connector JTAG. I have push buttons for the functionality. I have supplies. This supply is providing the supplies over here, 12 volt supply, 5 volt supply, 3.3 volts, 0 volts for different operations in ARM LPC2148. I can make use of these supplies. It means I need to have connecting wires. I'll use those. And I have USB port here. You see, USB port externally can be connected to LPC2148, and I have DC motor and AC motor driving I need. For that I need driver ICs. That is, for example, DC motor driver IC L293D motor driver, stepper motor driver, like this. 12 volt relay is there, 4x4 LED keypad is there, 7 segment is there, 16x2 LCD is there, LDR sensor is there, LM35 temperature sensor is there, POT is there, UART1, UART2 is there, that is universal asynchronous receiver transmitter ports are there, max 232 IC is there to drive those things. It means the driver ICs along with the external peripherals are there with this ARM controller LPC2148. I can conduct so many experiments using this board. That is what we are trying to do by programming the IO ports of this IC. So we'll explore more on this in the next class or in the lab more. Nothing to worry. How to utilize this board. Before that, how to do the simulation with ARM7, that we'll see in the next class. We'll stop here because next class again it is there at 10 o'clock. I'll stop here, take a break for 5 minutes. I'll stop here now.